Alright guys, in this video we're gonna be cover a brief introduction to functions of several variables, and cover perhaps one or two um, applications of functions of several variables. So we'd like to start out by consider this equation c of x equals 500 plus 7 dx. So this would be a weekly cost functions for producing X number of boards per week. So let's say X is the number of boards, uh, boards produced per week. And C of X is the total cost, weekly cost of producing X boards. Okay. So with the linear cost equation, usually we have this thing called fixed cost. So that could be just the cost of operating the manufacturer. So that's the fixed cost. And that's usually the y-intercept in the linear function. Then we have this thing called the variable cost. So fixed cost is 500 a week. And the variable cost is 70 per bore. Okay, so equation is 500 plus 70x. So consider this equation. Now, if the company decides to, let's see here, if the company decides to add a new type of board, call that the high performance competition board, to its line, and it says that if the fixed cost for the competition board is 200 per week and the variable costs are $100 per board, then the cost function must be modified. So let's see here. So now we're just going to look at just the total cost for the high performance competition board. Suppose call that Y. So Y, we're going to have the weekly fixed cost, which is $200, plus the variable cost times Y, where Y is the number of high performance competition boards produced per week, right, per week. Okay, so that's the total cost equation for the variable Y, or the number of high performance competition boards produced per week. Now, if we're gonna combine that with the C of X, okay, we can come up with a new equation. Let's call that C of X and Y. C X comma Y. So this stands for the total cost of the company producing two type of boards per week. So we can have the 500 plus 70x, which is the total cost for producing the standard boards, and then plus 200 plus 100y, which is the total cost for producing high performance boards. If we simplify that, that should give us 700 plus 70x plus 100y. So this stands for the C of X and Y. So we can think of this equation, this cost equation that we just wrote here. So we can think of this as a function of several variables. So this is the cost of functions, and this function depends on two variables, X and Y. Okay. So in this lesson, we're just going to briefly introduce how to evaluate these type of functions, and kind of make sense of it a little bit, interpretations. In the next lesson, we're going to also briefly introduce the marginal analysis of function of several variables, and as we recall, marginal analysis And that's another word for derivative. And we're going to be introducing what it means, how to calculate derivative of functions of multiple variables. But in this section, we're just gonna look at on the basic example how to evaluate function of several variables, and it's gonna be very similar to what we've done in the past. In this case, we're just gonna have more than one number to plug in. So consider this equation: cost of 700 plus 70x plus 100y. I want to calculate. We want to find c of 20, comma 10. So this means you know, x is 20, y is 10, and we want to calculate, calculate the total weekly cost of producing 20 standard surfboards and 10 high performance competition boards. And the total weekly cost would be the C of 20, comma 10. So we're just gonna plug these numbers into the given equation respectively. So we got 70 times x is 20 plus 100 times y is 10, and that should comes out to be $1,900 per week. Okay, so if the company decide to produce 20 standard boards and 10 high performance competition boards, then the total cost for that company is going to be $1,900 per week. Okay, so that's what it's saying. 1,900. So, formally, we can say that as at the current level of 20 standard boards and 10 competition boards, the weekly cost is $1,900. Okay, very simple. All right, so let's do another example I have written down here. So this is going to be introduced the demand the demand concept of what it means when you charge a certain price for each board, and how does the demand fits in, and how do we calculate the revenue in a sense of using function different variables. So we have r of xy and c of xy, and also p of xy as well. Okay, so we want to calculate those. All right, so using the same surfboard company, they determined that the demand equation for its two types of boards are given by the following: P equal to 220 minus 6x plus y, Q equal to 300 plus 3x minus 10y. So what this is saying that P, given that P is the price per board standard, let's do standard, per standard board, meaning the for the x variable. Okay, and then Q is the price per competition board. Okay, and we want to find the weekly revenue function, which is r of xy, and then evaluate that function at 20, 10. All right, so recall revenue is always equal to the number of units sold times the price per unit, right? Okay. Or you can say units demand if you want to, units sold or units demand. Okay. All right. So For units sold, in this case, the company has two different type units, two different type of boards. So we can say that we can have X, which is the standard board, and we can have the Y, okay, which is the competition board. And then price per unit, in this case, we have price per X board is P, and then price per Y board is Q. So we can now rewrite our revenue functions as X, which is number of units sold for the standard surfboards, times price per board for that, plus Y times Q. Okay, so that's going to be our new revenue functions. So that will become R of X comma Y using the formal function notations. And we now replace P and Q in terms of X and Y. So P is 220 minus 6X plus Y plus Y times Q. Q is 300 minus plus 3X minus 10Y. Okay. Distribute and simplify, combine like terms. That should give us what? Let's see here. That should give us 210x plus 300y minus 4x squared plus 2xy minus 12y squared. Okay, so you can verify that on your own there. That is our revenue functions, the function of x comma y. And if we want to evaluate r of 20 comma 10, we plug those values. So remember, this is your x, this is your y. We plug those values into the x and the y and evaluate for the answer. Okay. So that is 210 times 20 plus 300 times 10 minus 4 times 20 squared times plus 2 times 20 times 10 minus 12 times 10 squared. And if we calculate all that correctly, that should give us the total revenue is 4,800 per week. Okay, so that is the weekly revenue. All right. Now the part B, we want to find the weekly profit. I didn't give myself enough space here. I'm just gonna get you started in this one. I'm gonna go down here. I'm not gonna fully finish the work, but we know that in general, profit, part B, is equal to revenue minus cost. Okay, we got the revenue functions in part A. We want to subtract the cost equation given in this problem, and our profit is capital P of x comma y. Okay. So we use our new revenue function, which is found subtract the cost equation that given in the problem right here, and we simplify that. That should give us the profit function is 140x. You can verify this on your own. Minus 4x squared plus 2xy minus 12y squared minus 70. All right, so you can start evaluating some numbers with these functions, and in the next section we're going to talk about how to interpret the marginal analysis of these functions, costs, revenue, and profit in with several variables. Okay. One example I want to get to do in this video is this function called this right here, this weird looking functions f of x, y. So this is called the Cobb-Douglas functions. Douglas functions. So what this function does is it measures the productivity of a single company producing certain number of units, and your inputs are X and Y, where X is the number units of labors, like number of workers, things like that, and then Y is the number of units of capital, like machinery and stuff, and the output of this, or f of x, y, will be the number of units produced for a single company, or even an entire country. Okay, so in this case here, it's asking us to find f of 1,000 units in labors and 2,000 units in capital, and we're just going to plug this into the equation and use a calculator to calculate the result. Okay, and that should give us let's see if I do the math correct, that should give us 17,411 units roughly. Okay, so we'll come back to this Cobb-Douglas function in the next sections and look at the marginal analysis of it. All right.